This lesson, we are going to generate the product rule from the first principle. So first, let's write down the first principle. F prime, which is the slope of a tangent, is limit h is approaching to 0, f of x plus h minus f of x divided by h. And then we have to find what will be f of x plus h. So given f of x is ux times by vx, then f of x plus h will be u x plus h times by v x plus h. And then we substitute into the first principle. Now, in order to find the limit, we need to be able to fetch out the h in the denominator. However, there is no way that we can simplify the numerator to generate a h. Therefore, we have to use the definition of principle again. By the definition of the first principle, we know u prime can be written as limit h is approaching to 0, u x plus h minus ux divided by h. Now, let's modify our equation. F prime x equals the limit h is approaching to 0. We copy down what we had previously, and we have to subtract u x plus h vx. In order to balance the equation, we have to add the same term back. So we are adding a 0. That means we are not changing the equation. And over h. Next, we're going to factor out the numerator. So for the first two terms, you have ux plus h in common. So left over vx plus h minus vx. Plus, the next two terms, they have vx in common. And you have ux plus h minus ux left in the square bracket. And over h, but I can break into two fractions. So that's over h for the first one, over h for the second fraction. Next, let's use property of limits to break them into 4 different limits. So limit h is approaching to 0, ux plus h. Multiply by limit h is approaching to 0, vx plus h minus vx divided by h. And plus limit h is approaching to 0, vx. Multiply by limit h is approaching to 0, ux plus h minus ux divided by h, and close bracket. Next, we can say f prime equals 2. Now let's put 0 into h. So when 0 into h, you have u x plus 0, which is u bracket x. That's the first square bracket. In the second square bracket, you can see this is actually definition of the first principle, which is v prime. Plus, the next one, because there is no h, so limit h is approaching 0, vx, it just becomes vx. And the next bracket, you can see this is a definition of the first principle again, which is u prime. Therefore, we can say f prime x will become ux, v prime x plus vx, and u prime x. Let's rearrange them. So we get u prime x times by vx plus ux times by v prime x. And this is the product rule. Therefore, we say if the given function fx is a product between two functions ux times by vx, then your differentiation will be differentiation of the first function times by the second function plus the first function times by differentiation of the second function. Let's do some example. First example, you will see a function f(x) is given and is actually a product between two functions. So I'm going to use method 1 using power rule. If I want to use power rule, I need to have individual terms. That means I have to expand it. So x squared times by x will get x to the power 3. And x squared times by 3, I'm going to get 3x squared. Negative 2 times by x will be negative 2x. And negative 2 times by 3, I'm going to get negative 6. The next step we're going to do is we're going to find the differentiation now. So you bring down exponent and exponent take away 1. So you're going to get 3x squared. Next one, 2, bring it down, but you have to times by the 3. So it becomes 2 times by 3 will become 6. X to the exponent, now 2 minus 1 will become a 1. Next one, minus 2. Now, this exponent's 1 here. So when you bring down the 1, 2 times by 1 is still 2, but exponent 1 minus 1 will become 0, and x to the exponent 0 is 1. So it just becomes negative 2 times by 1, which is negative 2. The next term, negative 6 is a constant, so the differentiation is 0. So we don't need to write this. Therefore, your differentiation will be 3x squared plus 6x minus 2. Next part, we're going to use product rule to differentiate the same function. So in order to use product rule, you have to define your two functions that are being multiplied together. So the first function, we call it u. So u bracket x equals to x squared minus 2. The next function will be v, which is x plus 3. And we're going to find the differentiation of each. So u prime x will become 2x. Remember, the constant term becomes 0, so negative 2 disappeared. And then we're going to find v prime x, which is differentiation x, which is 1. Differentiation 3 is a constant 0. And now let's use the formula. So the formula is fx equals to ux times by vx. Then the differentiation f prime x will become u prime x times by vx plus ux times by v prime x. So let's substitute what we have. So u prime x is 2x, and vx, which is x plus 3, plus ux, which is x squared minus 2, and v prime, which is 1. Now let's expand and simplify. So you get 2x squared plus 6x plus x squared minus 2. Collect the like terms, you will have 3x squared plus 6x minus 2. As you can see, it doesn't really matter which differentiation rule you use, you will have exactly the same differentiation. So, even though power rule is very easy to use, however, you need to have individual terms. So for example 2, if I want to use power rule, that means I have to expand the function g, and that will not be very wise to do so. Therefore, we will choose product rule to do it. Let's define our two functions that are being multiplied together. So the first one will be ux, which is the first bracket, so 5x cubed plus 7x squared. And our vx will be the second bracket, which is 2x squared plus x minus 4. And then we're going to find the differentiation. U prime x will be 15x squared plus 14x. And v prime x will be 4x plus 1. Then we're going to find what's g prime. So gx will be ux times by vx. That means g prime x will become u prime x vx plus ux times by v prime x. So that's substitute whatever we know. So u prime x is 15x squared plus 14x. And vx is 2x squared plus x minus 4. Plus ux, which is 5x cubed plus 7x squared. And we're going to times by v prime x, which is 4x plus 1. Since this question is asking for g prime at -1, that means they only want to find the value of the slope when x equals -1. They didn't ask for g prime x. Then we don't need to simplify it, so we can just substitute -1 into the x to find the slope of a tangent. Now we substitute -1 into the x. So g prime at -1 will become 15 minus 14, 2 minus 1 minus 4, plus -5 plus 7 times by -4 plus 1. That simplified it will become 1 times by -3 plus 2 times by -3, which is -3 minus 6, which is -9. The product rule may be extended to include products of multiple functions. So here we're going to see how we generate the product rule if there are three functions that are being multiplied together. Given the function fx is u times by v times by w. So we can write like this, fx equals to u v w. That's define another function k. That k represents u times by v. Then I can write fx as k times by w. And using the product rule, I can write f prime x equals k prime w plus k w prime. And that's fine. What's k prime? So k prime is u prime v plus u v prime. Let's substitute whatever we have now. So f prime x will equals to k prime, which is u prime v plus u v prime times by w, plus k times by w prime. And then that's expanded. We're going to have u prime v w plus u v prime w plus k is being defined by u v. So we can say u v w prime. So as you can see, when you have three functions that are being multiplied together, u, v, w, the differentiation will be u prime, v, w, v prime, u, w, w prime, u, v. So likewise, if I have another function, gx is u, v, w, k, then my differentiation will be u prime, v, w, k, plus u, v prime, w, k, plus u, v, w prime, k, plus u, v, w, k prime. This is called the extended product rule. Let's use the extended product rule to find the differentiation of f prime at 2. So we know ux will be the first bracket, which is 2x plus 1, and vx will be the second bracket, which is 4x minus 3, and wx will be x plus 2. And then we're going to find the differentiation of each. So u prime will become 2, v prime will be 4, and w prime will be 1. And let's find f prime x. F prime x will be u prime, which is 2, times by v times by w, plus w. Let's use the extended product rule to do example 4, as there are three functions that are being multiplied together. So let's define the function u, which is the first bracket, 2x plus 1, v, which is the second bracket, 4x minus 3, w will be the third bracket, x plus 2. And let's find the differentiation of each. U prime will be 2, v prime will be 4, w prime will be 1. Next, let's find the differentiation. So fx is u, v, w. That means f prime x will be u prime, vx, wx, plus ux, v prime, wx, plus ux, vx, and w prime x. Now that's substitute. So f prime x equals to 2 times by 4x minus 3 times by x plus 2 plus 2x plus 1 times by 4 times by x plus 2 plus 2x plus 1 times by 4x minus 3 times by 1. Once again, because this question didn't ask for f prime x, they are just asking for f prime 2. That means we only need to find the value of the slope of the tangent at x equals to 2. So we can substitute 2 into the x to find the slope of the tangent directly. Then we're going to have f prime 2 equals to 2 times 5 times by 4 plus 5 times by 4 times by 4 plus 5 times by 5 times by 1 equals to 40 plus 80 plus 25. So our answer is going to be 145. Therefore, slope of a tangent when x equals to 2 is 145 on the function f(x). Now, let's look at the power of a function rule, which is also known as the chain rule. And we will go over the detail on chain rule in another lesson. For example 5, I want you to pretend the function we have is f(x) equals to a to the exponent 6. That means I can write as expanded form a times by itself 6 times. Then, by using the extended product rule, I can write f prime x equals to a prime for the first one, a prime for the second one, a prime for the third one, a prime for the fourth one, a prime for the fifth one, and a prime for the last one. And then we can simplify this to a to the exponent 5 times by a prime plus a to the exponent 5 times by a prime and a to the exponent 5 times by a prime plus a to the exponent 5 times by a prime plus a to the exponent 5 times by a prime plus a to the exponent 5 times by a prime. As you can see, we have 6 of a to the exponent 5 times by a prime. So we can write 6a to the exponent 5 times by a prime. Therefore, we say if your original function f(x) is a function to the exponent n, then your differentiation of the function will be n, bring it down, the exponent bring it down, and the function to the exponent n minus 1 times by differentiation of the function g. So now, f(x) is given by x squared plus 3x plus 5 to the exponent 6. Then our differentiation f prime x will be 6, bring it down, x squared plus 3x plus 5, the base doesn't change, to the exponent 6 minus 1, which is 5, times by differentiation of the function inside the bracket, which is 2x plus 3. And that will be the differentiation of the f(x).